when you start wanting to learn about the Swift programming languages, you come over to the Swift programming language guide, and you can see that it starts off with the basics, and it goes into constants and variables, declaring constants and variables, etc., etc. But as you go down a little bit, you start seeing like type annotations and this, that, and the other. And then you start seeing type safety and type inference. And you start thinking, okay, what is type inference? So let's just go to declarations first of all. And we see to understand what a constant declaration is. And we see that we've got, let's go back here. We see that we've got let and then constant name, the type, and then the expression. And you keep reading a little bit further, and then it comes up with type inference. And you're like, okay, so it brings you over to the types page, right? And then you see that there's there's the grammar of the type, and the different types are function type, array type, dictionary type, tuple, optional, and so on. I can just keep repeating them. But then you start thinking, well, wait a minute, what is type inference? So you go down to the bottom of the page, and then it tells you about what Swift type inference is. And this is a fundamental part for you to understand really before you start understanding what a constant is, because it's going to help you a lot better. So with that said, we're going to skip over constants and variables, etc., these declarations here. But I'm going to try and teach you what constants and variable declarations are, whilst at the same time teaching you what type inference is. So really we're starting at type inference, and then I'm going to teach you about the constants and the variables. So let's jump over to Xcode. So to give you an example right now, if you just forget about programming, let's use our normal brain to infer something, right? You see on the table that there is a round green thing on there that looks like a ball, but it has some kind of like leaf coming out the top of it, and it's got a little bit like shiny, might have some speckles on it or something like that, but it looks really delicious. It looks like you can eat it. Now, you are more than likely thinking that it is an apple, right? And you would be correct in saying that I'm inferring that there is an apple on the table. So someone doesn't need to say, do you want to eat an apple here? They just need to say, do you want some fruit? And they're inferring that it's an apple that they're trying to give you, right? Because they don't want to insult your intelligence to tell you, this is an apple, by the way, this is fruit, and you eat it. Would you like to eat it? They just say, do you want some fruit? And they infer that you understand what an apple is, okay? So with that said, let's just say let for the time being. There's two different types of variables. There's let and then there's var, right? One is immutable and one is mutable. But let's just skip over that for the time being. Let's say that it's just a variable. So when we say name is equal to David, right? Well, when someone says their name, you know that that's a collection of letters. It's a collection of characters. Now in programming, we call them characters, okay? So this basically is D, then A, then V, I, and D, and they're all grouped together in something called a string, right? It's a collection of characters equal to be a string, all right? So this name variable, just by us inferring it, will tell us that it's a collection of characters, or a collection of characters is a string. So if we press the option key for the question mark and then click it, we can see here that it's given us the exact information that the compiler has inferred, and it said that let name is equal to a string, and that would be correct. Okay, now if we say then age is equal to 45, and we do it once again, we can see that it has inferred that it actually is an integer, all right? And then if we can say height, let's just say I am 1.85 meters, all right, or 185 centimeters, and we do question mark again, it's inferring that it's a double. Let's just not care about these types right now. These are what other programming languages would call primitive types, but Swift doesn't have primitive types, right? It has structs and so on, but that's another video for another day. But we can just say these are Swift's primitive types, but they don't call it primitive types, all right? So now that we can see it's inferring that it is a string, and it's inferring that it's a number or an integer, and it's inferring that it's a double. Now we can basically say we can tell it exactly what we want as well, right? and we can tell it explicitly that this is a string, right? Now there can be times where the compiler is unsure about what type it's inferred to. So, and that's why you have to give it a piece of information to tell it what type it is, because the compiler cannot infer it at compile time, or whilst you're coding, whatever the runtime stroke compile time that Xcode is doing for you. So this is inference, right? And you don't have to do it, but my personal belief is that if the name is, you can use type inference through the name, all right? And height in itself is a indication that it's a height, but you could then say height in meters, right? Would be a lot clearer, 1.85 meters. And then if we were going to do in centimeters, then we would say 185 centimeters, etc., etc. So the name of the variable in itself can help you to infer what type that variable is without actually having to do the old question mark type thingy bob on it to see what it is, right? So this is another way of doing it. So this is basically what type inference is. And the more and more you program Swift, the less you will have to actually use typing, because it's supposed to allow you to not have to write code, right? But it's allowing especially when you use let. Once you define a variable name and you add the value to the name, we can't come down here later on and say then David James Thorne. We can't do that because this is a constant variable, right? Which means that it's immutable, which means we can't change the assignment of the place in memory that it has. Once it's initialized, it cannot be changed after that. Now we could say middle name and then say, whoops, here, for example, we could initialize, or so we could declare the variable to be a constant, right? And then we could change this to be James here instead. And that would be perfectly allowable because we have declared it, and by the end of the code, it has been initialized, right? As you can see here, this is a time where you've got to, prior to assigning the value, you've got to tell the compiler, hey, this is the amount of memory that you need to save for this one variable, and I'm going to give you the information later, I promise you, all right? So if we remove the type inference for it, and then you can see type annotation missing in pattern, because you've got to tell it, hey, this is just a variable name, what type has it got? But because in the other examples we say equal, it can look at the right hand side of the assignment operator and say, I can work out explicitly what type this has. Okay, so this is why you have to give the type identifier, or the type itself, when you declare that one variable. With that said, I think I've explained type inference well enough, but in the up and coming videos I'm going to use the type inference a lot more and so on, because I like to explain what I'm coding. But the best way to without having to use the question mark is basically to make the name of the variable explicit about what type data that is, and also what it does. But that's another video as well. With that said, thank you very much for watching, and ciao ciao, goodbye.